Hi, welcome to this episode of ProofPilot. We are over subspace topology or subspace spaces. Now we are reached to product spaces. So by definition, these spaces actually use the Cartesian product, and we define topology under Cartesian product. But we don't do this. We don't define this topology in the normal way by saying what the open sets are, but by defining what their basis is. So is the product topology is the topology generated by the following basis. So this is the basis we have. As you can see, it's the Cartesian product of all those open sets that we had in each of these xi's. So I just need to prove that this thing is in fact a topology. And when we define a topology from its basis, we just need to verify that this thing is actually a basis. So basis had two criteria, and when we say that this topology is generated by this basis, we just need to check two things. So the first one is for each member of your basis, we have to, if you take the union of all the members in your basis, you have to get the topological space, which here is going to be x1 Cartesian product, x2 and so on to xn. And the second one is if x is in b1 and x is also in b2, so it's in fact in their intersection, then there should exist a b3 which x belongs to, which b3 is subset of b1 intersected by b2. Prove that this two thing is in fact correct. For the first one, it's just really easy. This thing itself are open sets, so the first one is already satisfied. Now for the second one, we just need to write the definition of an open set in the product topology. So B1 is going to be the Cartesian product of some open set named U1, the Cartesian product with U2. Then B2 is going to be the U3 Cartesian product with U4. And the intersection of these two things, there should be another member of our basis that is a subset of the intersection of these two things. Well, we can use the property that this thing is equal to U1 intersected to U3, the Cartesian product U2 intersected by U4. And now, since X is a member of these things, then we know that this is a topology in X1 or Xi, and this is a topology in Xj. This is in Xj, and these things are topology. So the intersection of two open sets should be an open set, and we just name them Ui and Uj, and then X is going to be a member of Ui intersected by Uj, and this is going to be that B3 that we were looking for. So this is so the product topology actually exists the way we define it. If you enjoyed this video, please like and subscribe.